Hello, my name is Abinat. The focus of this project is configuring hybrid connectivity between Azure Virtual Network and on-premises network or simulated on-premise network in Azure environment. This project or the setup of this project will leverage powerful feature of Azure networking, including VPN gateways for secure communication of networks, the Azure firewall for centralized threat protection, the DNS to streamlined domain management, and NSG or network security group for granular traffic control at subnet level. This project demonstrates how cloud environment can securely communicate with on-premise infrastructures. This is essential for uh, business transition while retaining on-premises resources. So in this project, we have one scenario. The scenario is imagine one organization that's ready to elevate its operation by scalability, by embracing the scalability and the innovation of Azure. They want to connect with their on-premise network to Azure resources to ensure business continuity and operational efficiencies. The challenge is to create secure communication. This is a solution uh, by using different advanced feature of Azure networking. So now let's walk through step-by-step guide of the project. This is a documentation of the project here. This is a documentation of the project, including diagrammatical representation. So the first thing is we have to create virtual networks in both sides. We simulate the on-premise network in Azure environment and the virtual network again in Azure environment. So this is a virtual network and this is the on-premise network. In virtual network, we segmented the network into three subnets: apps, gateway subnet, and Azure firewall subnet. These two subnets are special subnet or dedicated subnets to contain or to deploy specific resources. In gateway subnet, we can only deploy virtual gateways and we can't deploy other things. In Azure Firewall Subnet, we deploy only firewall. We can deploy other resources. So on-premise network, we segment the network into subnet, gateway subnet, and on-premise subnet. So here, so we created two virtual networks here, Azure VNet and on-prem VNet. I used to create these virtual networks, the bash scripting language. So we can see the bash scripting language here. This is the bash scripting language to create the virtual network, including the address prefix and the subnet prefix. So in this way, we created this virtual network. So the second step is to create the subnet gateway, the gateway subnet. So I also used bash scripting to create the gateway subnet. This bash scripting is very important to automate the creation of resources. So now we have virtual networks and their corresponding subnets. The second step is configuring their VPN connectivity. When we configure VPN connectivity, there are three resources. The first one is VPN gateway, the second one is local network gateway, and the third one is connection. So we create VPN gateways in both sides with their corresponding public IP address and the local network gateway in both sides. This local network gateway is a representative of the corresponding network or the opposite network we are going to connect with. So this local network gateway contains the public IP address of the virtual network in other side and the address space of that virtual network. So here is a diagrammatical representation. The local network gateway is here. Here is the gateway subnet, and the same is true in other side. And we create connection between these two networks. So we can see virtual network gateway in the Azure portal. Virtual network gateways. So we have created two virtual network gateway, VNG Azure VNet in the Azure VNet side and VNG on-premise on the on-premise side. And we created the connection between these two virtual network gateways. So we have done with the connectivity of these two virtual networks. So throughout this project, I used bash scripting to create all resources. So we can see the bash scripting I used to create the virtual network gateway. Here is the bash scripting command. So with its corresponding PIP or public IP address, but we have to create public IP address first. This is the way I created public IP address in bash scripting. So now the same is true for on-premise side. We can see the public IP address here and also the VNG on-premise side. So now we have done with the connection of these two networks. The third step is implementing the Azure firewall for security. So we will deploy Azure firewall in the VNet side and their corresponding rules. In Azure firewall, there are three rules. The first one is NAT rule for network address translation. The second one is network rule for for source or destination address protocol and ports, and there is also application rule for fully qualified domain name or of FQDN. So we will configure, I configured these networks or these rules in the Azure firewall. So here is the scripting language I used to create. So first I created public IP of the Azure firewall. Then the public, the subnet contains the firewall that's called Azure Firewall Subnet. It is specific and dedicated for firewall only. The third step is creating the firewall. Then the fourth step is attaching this public IP address with the firewall and the corresponding VNet. In our case, the VNet is Azure VNet, and the subnet is here Azure Firewall Subnet. So we can see in the Azure portal the configuration of the firewall. So here I have the firewall, Azure firewall, and we can also see the rules. The rules are found in classic rule section. So click on rules in the bracket classic. Here there are three types of rules: NAT rule, network rule, and application rule. Then we will configure these rules. We will configure these three rules by using bash scripting language, and we can also see how we create those rules. Here, the first one is the network firewall rule, the network firewall application rule. So we allow only www.microsoft.com for outbound traffic, but other fully qualified domain names are not allowed to go out from the app subnet. The second one is the network rule. We allowed ICMP, that means the pinging connection between virtual machines in both networks. We will see them. Then the last rule is the NAT rule. This NAT rule is very important to access virtual machines remotely. We used as the source address, as a destination address, the public IP address of the firewall, and this public IP address will translate the incoming traffic into the private IP address of the virtual machine. It will direct to that traffic to the virtual machine. Here 10.2.1.4 is the IP, the private IP address of the virtual machine. So these are the three rules we have configured on the firewall. So in the application rule, we allow only www.microsoft.com to access this page from the internet, but other domain names are not allowed to go out from the app subnet. We can see here only www.microsoft.com is allowed. Here we can get the page of the Microsoft, but let's check another domain. Let's say www.google.com. Here we can't access this page because the firewall protects this traffic from going to the internet. It's unable, but we got this page from Microsoft. This is because of the configuration of the firewall in application rule. The second one is the firewall network rule. So we allow ICMP protocol in both sides, on-premise side and on Azure side, by pinging their IP address of the private IP address of the virtual machine. We can see it by getting the IP address of uh, one of the virtual machine. Let's say this one, this virtual machine, it's the virtual machine in on-premise network. So copy, and we must get the reply here. We got the reply. This means communication or connection is enabled between virtual machines in both side. So that's good. The third rule is the NAT rule. So here is the NAT rule. So it allows remote access of the virtual machine by using its private address and the firewall of public IP address. So to do this, we go for remote desktop connection here. So this is the public IP address of the firewall. So we can connect with uh, the virtual machine, because this public IP address will be translated into the private IP address of the virtual machine. So this is a configuration of Azure Firewall. So this is a diagrammatic representation here. So the fourth step is creating private DNS zone in order to manage domain name system, because it is it's difficult for human beings to remind each and every IP addresses. So instead, we can remind domain names. So in order to resolve this domain name, we will connect those on-premise networks and the virtual network to the DNS zone, and we added record sets. So let's say on-prem vm.contoso.internal. Here, this is the name of the virtual machine on the on-premise side. So we got the replay. That means this DNS zone is able to resolve this name. So let's see the configuration in Azure portal. So search for DNS. Actually, it's private DNS zone. So click on private DNS zone. We will get one DNS zone that's created using bash scripting. Here, contoso.internal. This is the domain name I used to check the pinging of the virtual machine on the on-premise side. So this is the way here, DNS rule. This is the bash scripting command to create the DNS to add record set on the DNS. This is the bash scripting I used to create this resource here, contoso.internal. So we are able to resolve names now. So the last step is creating network security group. This is a diagrammatic representation how we connect these two networks into DNS. So the last step is network security group. We apply network security group at subnet level to allow RDP or remote desktop protocol. Here is the bash scripting command. We allowed RDP. So this is a bash scripting command I used to create the NSG rule. The direction is inbound. Source address prefix is here. It is the firewall private IP address, and the destination is here. This is a private IP address of the virtual machine. So now we are able to connect with the virtual machine, but other protocols rather than RDP are not allowed to access virtual machine. This is how we secure our resources in Azure environment. So this is all about the project. Here is a diagrammatic representation to apply network security group. So this is how we configure hybrid connectivity between two networks. So these all IP addresses, including public IP addresses and private IP addresses, will be deleted after this project. So anyone can access these resources by using this public IP address. Thank you.